Can you hear me? Hi. So I'm Sam Aaron, and I'm going to talk to you about something which is very personal to me. It's the current stage of my journey of exploration about what this stuff is. And so please excuse me if what I'm saying isn't necessarily as clear as it could be, because it's something I'm still trying to understand and trying to work out the best way to explain. And so the way it should be is if I say something that you don't quite understand, please throw your hands up, we'll have a question, and then make sure that you actually are following me, otherwise there's no point at all. So that's the sort of the general principle. And so what am I doing and why am I here? What am I talking about? I'm excited about diagrams like this. Do people recognise these kind of diagrams? What do you think this is? Hands up who thinks they have an idea what this could be. Yep. A graph, yep. What kind of graph? Where would it come from? Where would you draw a graph like this? Any question? Any answers? Do you normally expect to see a graph like this somewhere? Where would you see a graph like this? Do you not see a graph like this? No. Are you programmers? Do you program? Yeah. Engineers, maybe? Like you might see this as a network. You know, there's some sort of way to actually draw a topology of some computers connected together, for example. Interesting thing about this diagram for me, though, is that it actually came from a book written by an architect about design in the 60s. So here we have an interesting combination of sort of mathematics. You also use actually mathematics to describe the weights of these things, to talk about how a good design needs to have a separation of concerns, such that, if you can see this as a node on the right here, was a collection of nodes, if a failure happened here, these lines talk about dependencies. If a failure happens on this node, it only affects the nodes it's connected to. So there's very little coupling, so that there's not that much effect of one node affecting the other. So he was talking about this as a design of a kettle, I think. It's quite interesting. This guy is quite famous. Everyone's probably quite heard of him, because he wrote this book called Timeless Way of Building. So the previous one was from something called Notes on the Synthesis of Form. So he's an architect who has a fundamental impact on some computer science, because he wrote a book which then people read and went, cool, those ideas are really useful in computer science. And the Gang of Four wrote the so-called Gang of Four wrote this design patterns book. So has anyone heard of design patterns? Come on. Yeah, that's 4, 5 people. Only 5 people? Come on. I don't necessarily agree with them, actually, to be honest. I think that they're a bad idea, but it's an interesting way that you can actually take ideas from architecture and bring it into computer science. And so what I'm trying to describe here is that when we work I'm a researcher, when we work in our own fields, it's very easy, very tempting to sort of keep narrow about what we're doing and only look at the kinds of people who are doing similar work and taking ideas from them, which is also very useful. But it's also amazing to actually consider how completely different fields can have a huge impact on the work you're doing. So in this case, architecture influencing computer science. And so that's who I am. I'm looking at trying to work out how we can take other fields and understand them and take ideas. And another part of trying to work out who I am is to try and figure out what analogies I use to describe myself, and probably do the same as well. When you talk to people at parties, and they say, what do you do? And you say, you're a programmer. And they say, well, what does that mean? What is that? How do you describe a programmer? So often people might say something like, I'm an engineer. I build things like bridges. So obviously you don't, these people don't typically understand what software is and don't understand what abstraction is and language and all sorts of stuff. But you can sort of draw an analogy with a bridge and say, well, what we're doing is I'm working with a team of people and we're building this thing which will be completed, and it has a deadline and it has some use requirements and it has a specification, and we know when we've got some tests to say that we know when we're done. So an engineer is a typical. So who might describe themselves as an engineer in this room? Oh, that's quite a few. Oh, quite a lot. That's interesting. Other people might describe themselves as a craftsman. I'm a craftsperson. What I'm doing is forging software into new possibilities. I'm actually smashing the molten iron of software. And I'm using techniques which have been passed on from generation to generation. And it's a trade, and really to learn the trade you have to work with amazing other craftspeople. So pair programming might be a kind of thing you might do. Spending time with other programmers is an important thing. So who might describe themselves as a craftsperson here? Yes, there's a few. That's good. Yeah. So there's also a crossover. You're not one or the other. So there's other types of craftspeople as well. So this person's sort of molding the software, through a process of interaction, like very direct interaction. And I think this is the kind of thing I would probably use to describe myself, in the sense that the stuff I'm doing is very much alive in the moment, and we'll talk about it more later. Architect is an interesting one as well. So this is a Bauhaus design. often people call themselves software architects because they're planning and designing, and they're trying to draw a vision of what the software is trying to do. And they may not even actually be part of the process of building it, but they're certainly part of the process of specifying it. So who might call themselves a software architect here? One person, three, 4 people. Another one, which I don't think many people would use, but I think it's an important analogy, and I'd like to explain it to you, is that of a software communicator. So certainly in businesses, one of the key roles of software developers to try and translate ideas from a business into the computer. Now, we're translation people. And certainly, that it doesn't even limit ourselves to that. We sit in business meetings where we actually listen to what the business needs are, and we actually say, well, those things, they're very hard to actually write software to do, or those things actually quite trivial, or this thing definitely has an advantage, or we can take this thing we've already built and modify it in these ways. And that's part of the process of communicating the ideas of software. The reason why I've got hand shadows is, well, A, they're awesome, and B, part of the communication is actually understanding that you're dealing with language. So in the case of this guy's hand here, his hand could be your programming language. And that's not really what the business understands. They see some sort of reflection or if you shine the light of the computer interpreter or the compiler, it projects the actual the artifact that the business can see. So one of your jobs is to manipulate these weird, crazy symbols in the same way that guy's hand looks very contorted, to generate something which people can perceive and understand. Does that make any sense? Who might call themselves a software communicator? We're in a Linux group, right? Okay. I would definitely call myself a software communicator. So here's the turtle, and here's a face. Look, I love that one. I wish I actually should practice being able to do these. They're lovely. And I think this is fundamentally important. As developers, we need to understand that a key part of our role is to actually communicate and share ideas with other people, and to actually make sure that we're working together effectively. Another one is artist. So has anyone here heard of Why the Lucky Stiff? 1, 2, 3 people. Great. So you might recognise this diagram. I stole it from Why. This is Quill, Why's sister, in fact. But I've sort of mutated her and turned her into an artist. I think Why the Lucky Stiff should be mentioned more at conferences like this. But this is a logo I've created, or I've stolen and modified, for something called Quill, which is a front end of processing written in Clojure, which I've written. But the reason why I have this on here is that I think it's also important to consider ourselves as software artists. So we're actually have a close relationship with the kinds of processes and ways of interaction that artists have with their work. And interestingly, this isn't very trendy to call yourself a software artist, and certainly in a business context, people are like, what the hell, that's not very good. I want to be an engineer, I want to be an architect, I don't want to be an artist, fanning around. But it's important because artists have an amazing way of working and interacting with their medium. And they're very much, it depends on the kind of artist, but they're very much philosophizing and trying to understand the deeper meaning of what they're trying to do. And of course, a lot of people do that with programming as well. When we have language wars or editor wars, a lot of that actually comes from having a deep understanding of the philosophical underpinnings. Like, I like Emacs because I can completely modify everything on the fly all the time. Or I like Vim because I'm definitely a mode person. And so this is important. And also, artists they're very creative in a sense that issues become opportunities. And that's also a fundamental thing about software as well. And so, yeah, I think I'm just trying to sort of paint a picture of where I'm coming from to try and get to get you to see what's going on in my head, because it's a bit weird. And so the next phase of trying to convince you about what I'm trying to do or communicate is chess, obviously. That's the next, obviously, step. So this is Garry Kasparov famously losing against Deep Blue. And it's it was quite an epic battle, and this is interesting to me, not just for what happened. In fact, it's interesting that humans at this point became inferior to computers in the game of chess. That's interesting. But what was really interesting is what he did afterwards. Does anyone have any idea what Kasparov did after he lost? Yeah, no one knows about this. It's interesting. So he created a new game called Advanced Chess. Yeah. So what he essentially would do, he would play chess with his other grandmaster mates, and they would sit with the computer by the side. So he'd essentially be this IBM guy, and he'd essentially just cheat. That would be it. So he'd play chess with a computer with all the best software on and cheat. And what was interesting is that him plus the computer could always beat the computer. So he could beat Deep Blue with this approach. So the combo of the human and the machine is actually the current best chess combination we have. That's also quite exciting. So humans plus computer, human. But what was really interesting is he had an online competition where anyone could enter using any approach. And he'd obviously been practicing with his Grandmaster friends and with the laptops, and he'd been cheating for a number of years. And well, it's also interesting for him in the sense that people would say it was cheating, and he would say, well, actually, it's not. This is fantastic, because what happens is I can actually not worry about whether the move I'm making is a particularly good one or not, because the computer can tell me that. So what I can use my brain for is the creative aspect. So I can say, is this an interesting tactical maneuver? I can look at the psychology of the game between the other player. And so he was saying that using the computer actually freed his mind to do the more interesting parts of chess, which is sort of the takeaway point here. But this online competition where anyone could enter using any move, and he'd been practicing for a while, he didn't win. It was quite surprising. 2 random guys from America won. Beat Kasparov, beat Deep Blue, beat everything. And no one had ever heard of these guys. They're obviously good chess players, but they weren't grandmasters. And this shocked Kasparov, and he came along with this quote, that a weak human plus a machine but a better process was superior to a strong computer. So if you've got not a very good chess player plus a computer plus a good piece of software, you can beat a good computer. That's awesome. But more interestingly, you can beat an awesome chess player with a computer. This is quite, I think, fantastic. And so I'm interested to know to what extent this thing can apply to other fields and other domains. So as software guys, this should excite you beyond belief. You can use your software skills to do things that other people could only dream of. By building cool software, by giving yourself ability to interact with an environment, you can actually build things that allows you to beat Kasparov at chess. That's awesome. This is what we can do as software developers. I think this is fantastic. So what other things can we actually apply our minds to? What can we build to make our opportunities broader and greater? And I think this is a fundamental future, of software, in the sense that we're having more people building things to not just build some software tool for some business that formalizes some process, that sends emails, and buys some stock and sells it, whatever. We're building tools, and we should be building tools that allow us to be more effective humans, to allow us to communicate more, to be more creative, and allow us to actually essentially, what would you say, like be able to communicate your inner self a little bit more, and essentially that's what I'm doing. And a lot of this thing is sort of built on the notion of ephemeral software. So this is also quite a new thing. And I think this, a new thing for me in terms of discussion. I don't hear people talking about it very much. Typically, so this is closer akin to the artist's view of who you are rather than the engineer's view. So the engineers are building something that is not likely to change in the future very much. So the bridge is going to stay there for 100 years, hopefully. A lot of software we build has a life cycle that extends more than days, hopefully to years or tens of years. I've written software which is running 5 years ago and it's still running now every day, and I get an email from it. This is sort of the engineering process. Ephemeral software is different. It's thinking about software not just as an engineering principle, but as an artistic principle, in the sense that we're building stuff that we throw away. So we have this word ephemeral in English. I don't know. Do people know what ephemeral means? It's an awesome word, so you should learn it. Ephemeral comes from nature. It talks about transience, things which change and go away very quickly. So there's no permanence with this. And so ephemeral software is software where you build it and throw it away. So maybe it has a useful lifetime of 5 minutes, or maybe an hour, or even seconds. And so why the hell would you build software that you're going to throw away? I guess that's an interesting question. It's very expensive to build software. We shouldn't be throwing it away. Well, if you can build software which is focused on the ephemeral, lasts for a very short amount of time, the main purpose of that is it allows you to have a conversation with a system or an environment that allows you to gain deeper insights to that situation. So you can imagine you writing that software in a way of asking a question of the system. So in the same way that these guys who beat Kasparov, they probably had awesome ephemeral software that allowed them to write software on the fly, which gave them more opportunities for moves. So they weren't just given a set of options. They were probably able to program the system live and modify it live. And I think this is an interesting thing. So this comes to me. So here I am at a Ruby on Rails conference. But you can't really guess what I'm doing. I could be checking my emails or IRC. Interesting, I'm projecting, as my friend Jeff as well, we're projecting our code on the screen, and it's actually Clojure code, not Ruby. So that's quite interesting. And we're not building a website. We're not doing any newfangled, message queuing system with asynchronicity, that's calling some whatever Erlang thing in the background. We're making music, which is quite interesting. And this is definitely in the thing about ephemeral software. So the stuff we're writing on the fly to make the music is just there for that music session. We delete it afterwards. Maybe there's some elements that we think are cool, so we build into a library, perhaps. But the majority of the software we write on the fly has a lifetime of that performance. So here's me again, programming music. Obviously, I'm not normally programming, because look at my face, it's ridiculous. Contemplating what's going on. This is at Arnolfini Art Gallery in Bristol. It's one of the best live art galleries in the UK, and I dare say that Europe. And here I am, actually, so this is the same stage, so you can sort of see me in the bottom right there. There's a massive screen, it was quite daunting. And this offered me an interesting opportunity to appreciate what I was doing, in the sense that I had one of these sort of epiphany moments, where up to this point in my life, I was building software from an engineering perspective to actually build something which lasts, has permanence. And so it was definitely something that I appreciated in terms of something concrete. And maybe a lot of you would agree with that's the kind of thing we do. When you make a new OpenSUSE release, that's something concrete, that you want to actually to call and give it a name. And so here, what I'm doing here is actually building something on the fly, and appreciating, whilst I was in that moment, I actually thought, goodness, actually all this time, I've spent years building the software, and I spent months preparing for it. All this time, I've actually got this plan of what I'm going to do, and I could just execute it, doing this, and this, and then my performance is done, people will clap, it's all great. And so seeing it as sort of a formal process I've developed and designed. But instead, actually, I realised what I should be doing is enjoying the act of making music on stage. So it's almost like all my programming skills got to me at a position where I was on this stage in an art gallery, and instead of just doing what I thought I should do, I actually needed to stop and enjoy the moment of programming. So this is a very arty, farty way of thinking about things, and maybe you won't appreciate it, maybe you do, I hope you do. But it's interesting in the sense that when we program every day, it's almost like this. It's not too dissimilar. We're in this moment where we're actually having interaction with our system or our compiler or whatever kind of language you're using, where really the art of interaction actually should become an interesting thing. Because if you do become engrossed in what you're doing, if you do see it purely as an act of joy or an act of creativity or an act of you communicating yourself, then you enter the flow states. You become much more productive. Time goes away and into strange places. And I think that's an exciting thing to be thinking about as programmers. It's not just about the software we produce, it's how we produce it and the modes we go into. And you hear people talking about things like agile software development, where the old waterfall model of 6 months to a year between software cycles is crazy. We should have weeks between software cycles. Well, this is sort of hyper-agile in the sense that it's moments between software releases. That we're focusing really on the interaction, very, very live and tight. So I've written this thing called Emacs Live. It's awesome. It's just a way of actually just bootstrapping Emacs in a way that provides me with a lot of the tools I need to do this kind of thing. I'm going to demonstrate it later. And also a system called Overtone, and one of the principal architects behind this. I use the word architect. There's artist software artist behind Overtone. So Overtone is a open source music language toolkit system thing, which is quite comprehensive. So you can not only describe high-level musical compositions with it, you can also describe the low-level synthesis and combinations of the two. So last night I was trying to use it to perform at the Club Lavka, although you probably didn't hear it because I was told to turn it down, which is a shame. And a lot of these things are principled around ideas and technologies which haven't changed for 50 years. So this is a paper from the 60s, and look at this. So Max Matthews said, a computer can be programmed to play instrumental music, to aid the composer or to compose unaided. How awesome is that? This is like 60 years ago. And yeah, he basically he laid it all down. Like, this is how you can actually describe sound synthesis. Like, you just basically have the sound wave, which is where the speaker moves in and out, and you just take the value of where it should be, sample it frequently, and then if you just create the numbers and store the numbers, then you can play back the numbers and then turn them back into where the speaker should be, and you reproduce your sound. So this is how how you actually store and reproduce sounds. This was amazing in the time. Obviously, we take this for granted. This is how wavefiles work. But he also started to think about, well, if we've got a way of storing sound, how do we actually create scores that are like an orchestral score, where we can actually tell the orchestra how to play and what to play? So he came up with this notation, which is very simple, sort of function calls, where you sort of, the system steps through this thing and it tells it what the command is, in this case play for all these, the instrument to play, the starting time to play, and then the duration of which to play, and then some parameters which would modulate these instruments. This is fantastic. So in the same paper, he's described music, and he's described notation for orchestration, and he describes a notation for generating the instruments themselves. So it's a very simple data flow diagram, which are the things that those previous commands are modulating on the fly. So this is how pretty much all modern music systems work, for synthesis. Very, very similar to this. And here we have oscillators piping into other oscillators and adding together, and random number generators. So in Overtone, which is built on top of SuperCollider, we have sort of about 800 of these boxes to do all sorts of cool stuff with this. It's great. And we're also using a language called Clojure, and it's important to point out, because I want to talk to people about Lisps, they always give me this face, like Lisp, parentheses, it's ridiculous. And I mean, that's already a strange thing to do. But the strangest thing and the unfortunate thing is they conflate and confuse Lisp with Lisp, because Scheme is different from Common Lisp, is different from Clojure. They're fundamentally different languages. They just look the same because they have a lot of parentheses. But they're not the same language. Their semantics are massively different. So essentially, I mean, if you want to know what a Lisp is, it's just a syntactic style for languages. It's not a language, it's a style of languages. It's a style where the language is written in its own data structures, which has awesome properties which allow you to generate new parts of the language with the same functions and the same methods you use to do normal data flow and data manipulation. So if you have a list of numbers and you want to map it over some function to change it to a new list of numbers, the same code you write there, you can take a list of code and map it to a new list of code, which is awesome. So in Ruby, they could do this kind of meta-programming nonsense, but it was really hard and weird and it was not normal, whereas in Lisp, it's completely natural. So it's important to realize they're actually fundamentally different, and Clojure really represents an important state of modern art, really, I think, for Lisp style languages. And one of the cool things about it is this. I mean, this diagram is amazing. I could look at this for hours. And I could talk about it for hours. I don't know how much detail is actually interesting. I'm sort of ranting now about things. But one of the interesting things about Clojure is it actually has a notion of time. Most languages don't have a notion of time. We don't have before and after. Like any normal stateful language, you can bang on some data structure, but there's no real clear notion of before you banged on the data structure and after you banged on the data structure. Specifically in a situation where you have multi-threads. The only way you can try and emulate that is to use locks, but even that, as it starts to get complicated. Whereas Clojure has fundamentally built in a notion of time where things can't change, they're immutable, which means that you create yourself a list of numbers and you can't ever change it. It's great. So the only way to change it is to have a pointer to it. And then the pointer can flip between different things. And that pointer flips with concurrency semantics. So it really can flip with a CPU instruction. So there is no in-between. It uses compare and swap. And the cool thing is, in this kind of system, is that the number of observers observing the data structures doesn't at all impede on the ability to process the data. Which is, it sounds like an obvious thing. Like, there's quite a number of you here now. If suddenly there were to be 3 times the number of people in this room, would I slow down? I really struggled because so many people are watching me. I've somehow got to synchronize with everybody. We've got to have sharing locks, and you're saying, Sam, can you lock me so I can look at you, so he doesn't look at you at the same time because maybe you've changed. And this is what programming is like. It's ridiculous. Whereas if you've got immutable data structures and you're just looking at snapshots, the number of observers does not affect the ability to modify the data structures, which has really interesting properties. So I just really want to rant about that, and that's cool. So yeah, essentially, like a snapshot v1 to v2 is just a function between them. So you pass the value to a function, and the result becomes a new value. And you can hold on to v1 as long as you want. I can look at you now and close my eyes. You might have moved around, but it doesn't matter because I still have the snapshot of you in my memory. And so this is the same way as this works. And when no one's looking at a particular snapshot, then it gets garbage collected. So overtone Clojure punk. This is what it's all about. This is people hacking music in coffee shops, with each other, with headphones, not really looking at other people, and other people not looking at what they're doing, but having a good time. So this is an interesting thing. So when we talk about music, so this is another thing that gets me annoyed. And it's easy to get annoyed actually about this stuff. People say, I say to people, I'm making systems for music, and they say that's cool, but I'm not a musician. I'm like, what the hell? And they're like, no, yeah, I'm sorry, I'm not a musician. And what they're really saying is they're not a professional musician. They haven't trained for like 20 years to play the double bass. That's what they're saying. They're not saying they're not a musician, because that's bonkers. Everyone can get a stick and whack it on the table and make sounds and have fun doing it. That's making music. And so this is what Clojure punk's all about, sort of taking the idea of early punk where there was a time of ridiculousness in music where you had drum kits with 30,000 drums. And it's like, and a guitarist playing all sorts of crazy chord combinations. And the punk guys who went, well, sod that. We can just we can't do all that stuff. We can go on stage. We can play 4 chords repeatedly, really loudly, and have a lot of fun. And that's what they essentially did. So they sort of said you don't have to have all this complicated music stuff. You can just have a lot of fun. And so this is what you can do with programming languages as well. So coming back to the artistic expression, you can use programming languages to make music purely just to have fun. That's the important thing. And so what are some skills, to achieve all this? Trying to think about it. So touch typing. How many here can touch type? Right, so that's not enough people. You need to. So you're programmers, right? You should be able to touch type. That's a fundamental skill. Really, seriously, it's like saying to athletes, how many people can type your own shoelaces? Well, actually, I don't type my own shoelaces. Well, you need to tie your own shoelaces. When you're a programmer, you need to question. Touch type. Oh, right. So touch typing is like when you see Jimi Hendrix on stage, right? He's like giving it all this, shredding the guitar. But typically he's got his eyes shut because he's not actually looking at what he's doing with the guitar. Touch typing is be able to do that with programming. So shredding the code like that. So if you can type without looking at the keyboard, that's touch typing. Tool familiarity. This is an important one. This is the thing I'm sort of banging on about. How many people here modify their own tools to make software? 1 person, 2 people, 3 people. Come on, you're Linux guys. All of you should be doing this. I mean, you're programmers. So why aren't you programming the programs? That's crazy. Why not? Why not use your skills to make tools which make your skills better? That's a fundamental thing, And this goes back to the Kasparov thing, If you make tools to make your tools better, you can kick ass. You can beat Kasparov at chess. You can beat your fellow programmers. You can build awesome tools which make you better programmer. Sort of ends with this I like acronyms, or hate acronyms, actually. So I'm going to end with this. This is the fundamental message, so you should take that home. What this stands for, it's ridiculous, really, to be honest. Build your own lightsaber, yes. So, I didn't realise this, but the Jedi Knights, apparently, before they could become Jedi Knights, had to go off on an adventure and find the crystal for their lightsaber, bring it back, and they had to polish it and fashion it down and build their own lightsaber before they could become a Jedi. And so as software developers, you should be totally building your own lightsabers. So part of what Emacs Live is me hacking with Emacs, trying to turn it into something that's my own lightsaber. And then part of that is also saying, well, if you built something cool, you can totally share it, make it open source, and other people can then use it to build their own lightsabers. But this is a fundamental thing. And so I want to talk about that. How much time have I got left, by the way? Does anyone have any idea? What time is it now? What time is it? Awesome. So I've got half an hour, 15 minutes left. So I'll stop at this point for questions, and I'll give some demonstrations, I guess. Does anyone have any questions at this point? No questions. I mean, you're still here. I guess that's a good thing. There was one person asleep, but they've left. That's good. Okay, so would people like a demonstration of this, what I'm trying to talk about? Yeah? Well, was anyone at Club Kafka last night? 1 person. 2 people. Awesome, right, because it was rubbish. We were told to turn the music down because it was too loud, apparently, and so no one actually heard what we were doing. So maybe I can try and demonstrate some of it here now, and you could hear. Right. So let's go to the terminal. So I do use a Mac. I'm sorry about that, but it does work. And I do audio stuff, and audio on Linux is a complete nightmare. Please fix it. Please fix it. So this is what, when you start Emacs Live, it gives you this sort of pretty image. and makes me smile. These kind of things are nice, you know. It's like tells me to turn my head towards the sun, and the shadows will fall behind me. That's nice, profound. I'm using something called tmux here to multiplex the terminals. Here I'm firing up a terminal, process that starts the JVM, and will give me a REPL, which I can interact with. So this is typically how you might use Clojure to program. Starting up the JVM is so slow. Right. So you can see here now I can type 1 and it will evaluate that to 1. So this is standard REPL nonsense, but it's a bit like the terminal, but it's a programming language. And because of Lisp. I mean, how many people here program in Lisps or have programmed in Lisps? Cool. How many people here programmed in Clojure? A couple. That's cool. Awesome. Well, I'm pleased about that. So obviously with Lisps, everything's a list, and the first thing in a list is the function to call, and the rest are the arguments. Typically, that's the way it typically works. So here we're adding 1, 2, and 3. We're getting 6. And the nice thing is you can sort of add these arguments on, and you don't have to keep adding pluses in between. That's lovely. And so with Emacs, I can also connect to the same thing. So if I find a port which is 55897. I can have the same thing, but this is coming from Emacs, which is much better to play with, because I've got this thing called paredit, which automatically puts the ending parentheses, which is cool. And so this is part of like building your own lightsaber in the sense that paredit's cool, but there were some things which weren't quite what I wanted to do, so I modified it to make it exactly what I wanted to do. And part of this are bindings as well. But things like if I've got this list of +1 and 2, and I'm programming, and say I've got some numbers outside, you know. How would you normally put the 5 and 6 inside the brackets? You'd probably like go there, maybe if you're smart, do like Control-K, delete them, find the place you wanted to put them, and then like do this. You know, but because paredit understands that you're actually basically editing a tree, you sort of just suck them in or spit them out. Look at that. And so programming like this is just basically manipulation of trees, which is awesome. So you're no longer thinking about text, you're thinking about data structures. That just makes things much better. And like typically when you do Control-K in Emacs, it deletes the end of the line, right? And often then when you do that, if you're programming, you leave your program in broken states because maybe it's deleted a semicolon or it's deleted the end of or there's trailing things, and you just end up with a broken state. You have to fix it. When you're in parentheses mode, you can do Control-K, and it just deletes the sensible end. So even if that's across lines, you know, that sort of, actually it won't work in the REPL, but it will actually work across lines, which is awesome. Now, the cool thing about this is we can sort of use this thing called overturn.live, and it will then basically boot us into an audio environment. How cool is that? So this is sort of bootstrapping. Within Emacs, I've got Clojure, and then within Clojure, I've got this supercollider synthesis engine. This totally works on Linux as well, but it is the hardest platform to support. It's annoying. Right. Here we are, look, it's one of these stupid ASCII art things with a message. And we can totally just make a sound. Look at that, the beautiful sound of a sine wave. So here all we're doing is saying, can you demo me a sine oscillator? The default is 440 hertz, so it's basically the same as saying that. But you can sort of put your own frequencies in there, that's awesome. And it's cool because you can do all sorts of interesting things with it. So, but coming back to what I was talking about earlier, I mean, here I have an environment where I'm actually able to interact with it live and explore and experiment. And there's no compile time, although there is compilation. When I run this code, it is actually compiled on the fly in the JVM, but so quickly I don't notice it. So there is compilation happening. But I get this environment where I get interactive results. So I can go into other buffers, like we have this nice examples directory. And here's like this is cool. So this is the THX. Well, it's a poor man's version. This is the sort of cinema sound, like when you go to the cinema. Awesome! Look at that. That will go on all day, basically. You can change the volume as well. The cool thing about this, well, there's many cool things, is first of all, I didn't write it, someone else wrote it in supercollider, and I was able to translate it to overtone language. And this what you're seeing here, look at that, when I do the Control-K, it deletes the whole thing, that's awesome, look at that. that whole thing is all you need to make that sound. It describes every single part of it. So this is something that a normal person or a programmer can totally read and understand, spend a bit of time studying, and they can get the entire... So when I hear that sound, because I've written the code to generate it, I know exactly what's happening. I have like a deep insight to the way that the sound is being produced, which is fantastic. But it also means I can email it to someone else and they can do exactly the same thing. So when we're talking about synthesis and synthesizers, one of the issues with the 70s is, first of all, there was no real process of designing synthesizers, and it still isn't now. It was basically take a lot of drugs and twiddle all the knobs until it sounded good. That probably hasn't changed. But when you found a good sound, there's no way to really store it. Maybe you could say 2.3 on that dial and 4.8 on that dial, and maybe you could write it all down. But that would be a tedious job to do. Most people didn't do that. And then even if you did do that, to reproduce it, you need exactly the same synthesizer, which may be possible if it's off-the-shelf synthesizers. But even then, typically these synthesizers were analog, and room temperature would affect how they sounded. So even then, it was very difficult to reproduce this stuff. And so one of the impacts of this is that pretty much all modern electronic music is lost, in the sense that Mozart's music isn't lost. In that Mozart's music, there's a score that we have that we can study after he's died. We can have an insight about how he did the composition. And in a sense, this is sort of an open source approach. The source for the composition is still available, the notation. There is no source for any of Aphex Twin's tracks. There is no source. We can't compile the music and generate it from the language. That doesn't exist. So as programmers, this should worry us, and we should wanting to fix it. So this is a way to actually say, you can use language to actually describe complicated synthesizers in a way that can be stored and studied in the future. But you can also interact with these things live, so let's have a play with that. So, scratch. So this is, we can pull in sounds from something called Freesound. Have anyone heard of Freesound.org? This is a fantastic website. So these guys, university guys, have built this open source sounds storage website where you can put free open source samples, Creative Commons license typically, that are free to use. So you know how long I have to pay other people to play the samples. If you can find it on here, you can use it. So for example, this estlackliftb.afe. I have no idea what this is. You might like that. You might want to keep that. And so, yeah, you just need the number and overtone. And then you just see like def, whatever, crazy sound is a sample which uses the Freesound path. So notice here how it's auto-completing things on the fly. This is not exciting to people using crazy IDEs like in C++ or whatever, Eclipse or whatever. But this is interesting because this is a dynamic language, and this stuff hasn't been statically generated. There's not C tags or E tags or anything like that. There's no list of function names. This is live. This Emacs is talking to the Clojure runtime and saying, "Hey, I'm in namespace suzy.dnb. What are the variables that are visible there?" And it just returns you a list and then just prints them out. And then when you highlight one, it said, "Hey, I'm looking at freesound-info. What's the doc string for that?" And it prints it out. It's cool. And so as I create new functions, they become immediately available. So freesound.path. So this downloads, caches, and persists the Freesound audio file. Awesome. And then do that. We can then see look at that. It's downloading now. And so now I can just go to crazy sound. Probably turn it down because it was horrible. And it's available for me within my system, which also means that if I then email you this, you won't have that sample, but because it's on Freesound, you can automatically pull it in. So it's a way of sharing sample files, but without having to embed them in some sort of file. It becomes notation. So as long as freesound.org exists, this is going to work, which hopefully is for a long time. But you can do all sorts of cool things. Like here's ocean waves. Oh no, I need to make the mixer. Oh, okay. Yep. So here's the sounds of ocean waves crushing. That's lovely. And so you can sort of pull these things in on the fly and then start just playing. Yeah. So you can loop them. You can play some Tibetan monks chanting. So like in 3 lines of code, I've got drum and bass. How cool is that? And I can change the guide to make him play low. So this is really cool. You can do this like, within half an hour, just pulling all this stuff in. Aliens. Grenades. Right, so I mean you can see how easy that is. So like one line of code to pull in the sample, then you just call it as a function, crazy sound, and you're laughing. You can loop it by just passing the loop true, like this, and that's really all I did for like 3 different samples, and it was a lot of fun. So here you can sit in a coffee shop with your friends. You can get one of these little dongles where you can plug multiple headphones in, plug into your laptop, have a great time. And so you can totally mix this with MIDI keyboards. So we've got like everything's multi-core concurrent stuff. We have a crazy complicated but awesome it's like Node.js basically built into the system. So when you create events, so MIDI controllers or open sound control messages come in, they get executed on all the cores, and you can associate handlers to them of different kinds and styles that have different semantics in a concurrent environment. And all of this is really possible because Clojure provides a dynamic, flexible, interactive environment, which when we were talking before about artistry is part of that process. But also that the time thing I was talking before, the fact that you can actually store snapshots of things, makes it totally possible to write quite sophisticated multi-core software, such that I can totally have multiple threads running and not really worry about it because they're not really banging on things together and tripping each other up. How long have I got now? I've got 10 minutes left? 5 minutes left? Yes. Sorry? 10 minutes. Any more questions? How many people are going to play with overtone at some point? 2? Yeah, 3? Come on, I want to see more hands. 4, 5? Great. So what else could I show you to try and convince you to... So you can do... so also the quill thing, I'll probably show you that. So... it's probably not going to work actually because my Monome plugged in. I could show you this. So this is called a Monome. This is awesome. So this is like a modern art. It was in the Museum for Modern Art in New York. It's essentially a box with buttons which are lights. So that's all it is. And you can totally program this to do whatever you want. All these bloody wires. Just find the right one. This one. So essentially, when you press the button on the Monome, it sends an event to say, hey, a button's been pressed, and you can then do stuff. So you associate a handler, which calls a function. And the cool thing about that, actually, is that this software, because Clojure is immutable, the function which gets called takes 3 parameters. It takes the x and y coordinates of the button you press, and a state value, it's not a variable, a value, which basically contains all of the button presses in history since it was booted, and the timestamps and the current state of the lights. So your process can just bang on that for ages and do something interesting. So you look at patterns about, oh, hey, you press this particular sequence of buttons, or you're doing this chord of buttons and do something different, which is amazing. Right, so let's see if I can get this going. So one of the things about live programming is it always goes wrong. Like that's part of the deal, you know. That's the way you deal with that. So what am I doing? So viz, we can get this going. Maybe arpeggios. It's going to work. Horrible noise, stop. Sati. It's going to light up. Please light up. It's not lighting up. It's not lighting up. What about the Monome? Oh, now it's lighting up. That's good. Oh, yeah. I can play the piano. But I can even do, so hopefully the visuals will work as well. So if I show the petals, hide the sphere, show the petals, and hide the squares. Oh. Like these. Then if I make my window transparent. Oh, it didn't make a... There we are. So when I press the right hand, it's sort of there's flowers appear, which is awesome. So here I got the system where do you all know Eric Satie, piano composer? Yep. Do you know his Gnossi N number 1? If you don't, you will. I'll, play it louder. 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 Play it this on the train, down to London from Cambridge. Again, like the composition, the whole thing for this, so is cool. So you pull in all the namespaces you want. Then here is like a list of all the intervals of the SART piece. So basically, it just consists of those lines of code which describe the different parts of the piece. And then we use concat just to stitch them together. So like the left hand or this is the right hand. There's all these phrases one after another. You can even use like codey stuff. Like the left hand is phrase 1 base repeated 6 times. So you can use words like repeat. And then at this point, then you say, well, actually, let's make it into A flat 4 major. You can totally change the key at that point. And then coming back to this sort of immutable, non-mutable Clojure being cool for having values thing, the whole thing I just showed you there has just 2 things which can change, like where my left hand is and where my right hand is. Everything else is immutable. So it is interesting when you program in this way. Actually, you think you need all these variables everywhere. Like when I have a for loop, I'm going to have a variable which I set as 0, then I'm putting stuff into it, or I'm modifying it to actually get the results. You don't need any of that stuff. That's not actually necessary. You need very few things which can change in programs. Yeah, and that's what that is. And the visualizations is that quill thing I was talking. So that's processing and behind the scenes, which I'm just interactively creating and showing, which is cool. Maybe this might work. If this works, it's great. So here I've turned it into a sequencer. Pressing buttons and it's making a cool sound. And then you can do things like play bass, which goes in synchronization with it. That's a lot of fun. I can do that for hours as well. And again, all this stuff is open source. Like it's totally available for you to play around with. And the idea is that when people make a cool sound or a cool synthesizer, or they make a cool way of interacting, you just release it on GitHub, so everyone else can benefit. So the idea is that, I mean, I'm not a great musician, but I'm learning. And so as I make things, other people can take advantage of them. And other people who've got maybe more synthesis skills than I have can build cool synthesizers that I can use. So this is sort of taking the open source approach, but taking it to music, really, is a key. But just a quick recap on all the stuff I was talking about before. This is only possible when you perceive your interaction with software from an artistic perspective, and also consider software as an ephemeral thing. So all the things I'm doing here, there's live interaction, there's live manipulation. I'm not generating stuff which is necessarily going to keep. Maybe I've kept that buffer around, but all of the different things I was doing, the different modifications, I've not stored those. They haven't been persisted. It's all about this live interaction. And so considering software as an ephemeral thing is an important thing. You might not have heard of this term big data sort of throwing around a lot at the moment. I mean, from my perspective, maybe this is a naive thing, but at least from where I see it, big data is about the fact that we have lots of log files, that are around, that actually have a lot of business value inside of them, locked in. And so we want to write software which can actually parse and manipulate and generate new information from the massive loads of log files. That's also about ephemeral software in the sense that the business will say, hey, we've got a question, maybe the log files has the answer. So someone will write some code to see if the log files have that answer, and then they can give the answer, and then the code can just throw away. Isn't that said? Or maybe the answer is doesn't have that thing. I think there's definitely value in looking at ways of interacting with software where the thing you're producing isn't necessarily the actual artifact, it's the interaction which is the key. And also, when you're programming and you're building your own lightsabers, to just appreciate the fact that the act of programming is a beautiful one, and to enjoy it, and not get so worried and carried away by what you're producing, but enjoy as well. Spend some time thinking about how nice it is to actually be in a workflow with a computer and to actually build stuff with your own mind and with your own fingers, because we're only alive once, and it is a beautiful thing. Thank you very much. Any questions? Before I dash off for the plane? Yes, question. Oh, I wasn't recommending those books, to be honest. They were examples of books where you're taking ideas from one field to another. I don't recommend design patterns. I don't really believe in them myself. But certainly The Timeless Way of Building by Christopher Alexander is a beautiful book. And also the book before is called Notes on the Synthesis of Form, which is also a fantastic book, written in the 60s, but describes design from a mathematical perspective by an architect. It's just brilliant. And talks about the key principle of the previous book is the fact that language is a barrier for us to actually understand new things. It's a crazy thing to think about, but you should read it and find out what that means. Any more questions? Nope. Oh, one more, yeah. The question is, will the code for the demos be available? It's on GitHub right now. Look. GitHub.com/overtone/overtone source. Well, there we are. Overtone examples. There we are. All those different directories of examples. And if you find a new one, tell me and I'll add it there as well. One more question? With Clojure, the question is, what type of applications do I use, or is it in general people usually program with Clojure? Actually, it's an interesting question. There's a lot of growth in the Clojure community. There's tens of thousands of programmers now. It's seen adoption in systems which things like so there's elements of Twitter which are programmed in Clojure, I believe. Banks are using it to actually reprogram. But one of the beautiful things about Clojure is it's built on top of the JVM and has direct access to all of the JVM libraries without any wrappers. And so if you've got a massive JVM ecosystem and all sort of Java stuff, you can start porting bits of it into Clojure bit by bit. And so people with massive enterprise Java stuff are starting to actually use Clojure to pick off large chunks of code and really, because you can write the same functionality with a much smaller amount of code, and that way have fewer bugs, because the bugs are really proportional to lines of code and easy to read and maintain. So there is a large increase in enterprise development with Clojure. I guess is the answer to that. There's a really, on the mailing list, on the website, there's a nice list of companies using Clojure, so that's probably the thing to look at. It's on the clojure.org website. But yeah, but it's amazing. It's a pragmatic language which has been... I'm surprised, because I thought it was just a cool language which was enjoyable to learn, because some things are good to learn because the act of learning gives you new insights, and that's why I started learning Clojure. And I never thought that it was really going to take on as well as it has done. It surprised me, and it continues to surprise me. It is a fantastic language. Any more questions? More question? Yes? Have any commercial artists embraced... No. Not yet, no. I think we're still a way off from that. Certainly, the biggest issue is I started off with the ideas of the music thinking, because my PhD was in domain-specific languages. Like, can I build a domain-specific language which helps me communicate with musicians to build tools that they can use? And actually, the more I looked at it, the more I realized that for higher efficacy, and it sounds a bit sort of brutal to say it, that it's even been my experience, it's easier to teach programmers music than it is to teach programming to musicians. And so trying to work with artists, it'll have to be one of collaboration, not one whether they pick this up. I mean, last night at Club Kafka, the technician guy, he was like looking at the laptop where I had like this business going on. And he was like, what? You could see his eyes, like, that's weird technology. It's just beyond most people, because it is a programming act. So really, the target for Overtone currently, and probably for a long period of time, certainly from my perspective, is programmers. So I want to give programmers the ability to make music. Yeah. But it'd be awesome if some musicians were to appreciate what's going on and try to get involved. I mean, certainly SuperClide, which is a thing that Overtone sits upon, has been used by artists like Radiohead, for example. So, more questions? One more? No more. Sorry. So the question was, can we do this in Vim? You can do it with any editor that can connect to the yes. The answer is yes. There's something called Vim Clojure, which you should use. Vim's awesome. Yeah. Thank you very much.